Good day. So today we are on our day 12 of daily questions solution. So today we are just dealing with derivation from the first principle. This is calculus, guys. So if you want to derive from the first principle, this is what you do. So we're having our function that is saying f at x is equals to x squared minus 5. So what you do, firstly, you write the formula of derivation, right, from the first principle. So it means that we are going to say at x is equals to the limit when h tends to 0 of f at x plus h minus f at x all over h. So this is the formula that we are going to use to derive that. So let's carry on. So on our function, it means that to deal with this, so it means that everywhere where you're seeing x, you are going to place x plus h on this function. So it means that our derivation now becomes the limit when h tends to 0 of, here we can see x, so this is x plus h, but don't forget the squared. So that is squared minus 5. So this should be subtracting the f at x, the whole f at x. And what is our f at x? Our f at x is x squared minus 5. And don't forget to put over h. Now we are going to expand that. We can put 2 brackets, or if you are okay, we can just multiply the way it is, right? But let's just put 2 brackets just for in case. So this is the limit when h tends to 0 of x plus h, x plus h, and then minus 5. And this function here, we can see already that we're having a negative there. So this will affect everything inside the bracket, and negative will give us positive 5. And this should all be over an h like that. So again, this is our limit when h tends to 0, and now we can multiply out. So multiplying out, it means that x multiplied by x gives us x squared, x multiplied by there, it gives us positive xh, and h multiplied by x, again it will give us positive xh. Can you see that? And then h multiplied by h, it gives us h squared. And here we're having minus 5 and a positive 5, so we can quickly cancel that out. So minus x squared all over h. Still we can continue. So this is our limit when our h tends to 0 of what now? We are having x squared and negative x squared. So it means that this also can cancel out. And we're having xh plus xh, that will just give us 2xh. So this is just 2xh, and then we're having plus h squared. So plus h squared, and still we are still having our h. So this would be still over our h. So let's transfer whatever that we're having this side. So this, we said our is equals to 2xh plus h squared all over h. And don't forget that this is the limit when h tends to 0, right? So what are we having now? We can see that on this term we're having h, on this term we're having h, and on this term we're also having h. So it means that we can quickly factor out h. So this is still the limit when h tends to 0. If we factor out h, this is h, 2x plus h all over h. So now we can see that we can actually cancel out these h's, right? Still, this is the limit when h tends to 0 of 2x plus h. But we said that our h tends to 0. So whenever you can see that you're only left with only one h, it means that you can cancel out because our h is tending to 0. So lastly, now we can have our f at x, our f prime x being equals to 2x, and we have derived that from the first principle. So just like yesterday, I gave you 2 examples. So today I don't know how I will feel. Maybe I'll give you 3, but let me give you another one. I'll post the other one after this one. So if you have enjoyed, if you have gained something else, or if you think someone else will enjoy this, please share with them, like, subscribe, follow. See you on the next one.